Welcome back, algebra students. This lesson is solving 1 and 2-step inequalities. Now, solving inequalities is no different than equations. There's one little step you have to remember. So, let's start off by just looking at a quick investigation. If I take this inequality, 3 is greater than 2. Right now we can say that's a true statement. Now, if I add, say, 1 to both sides, I end up with 4 is greater than 3. Does that inequality remain true when I do add 1 to both sides? Yes. Same will happen with subtraction. And so addition and subtraction of the same number to both sides will keep the inequality the same. Multiplication. If I take 3 is greater than 2, if I multiply this side by 4 and this side by 4, I get 12 is greater than 8. Remains true. But say I take the same inequality and I multiply by negative 3. I end up with negative 9 and negative 6. Is negative 9 greater than negative 6? No. So what would we have to do to make this a true statement? You would have to flip that inequality sign. So when we solve linear inequalities, it is no different than solving an equation. First step, simplify both sides of the inequality sign. Then, we move the variables to the left and constants to the right by undoing addition and subtraction. Now, again, no different. We're going to undo multiplication or division. But, if you multiply both sides or divide both sides by a negative, you must flip the inequality sign. Okay? So let's look at a couple of examples here. Here, I have all my variables on the left, but I have to bring my constants over. How do I get rid of this 3? I go ahead and I add it. And when I do this, x is less than 8. Fairly simple. Okay? Number 2, I have all my variables on the left, but I got to move this 6 to the right side because it's a constant. How do I get rid of it? I subtract it. And I end up with 2x is greater than or equal to 18 minus 6 is 12. Now, to get x by itself, I divide by 2. Since I'm dividing by a positive, I have nothing to worry about with the inequality sign. X is greater than or equal to 12 divided by 2 is 6. The next one, anytime I have a fraction in front of the variable, I always do a two-step process. Multiply by the denominator. 2 is eliminate. 1x is greater than 6. As of right now, I'm good. But some people get confused with the 1x. Even if I divide by 1, x is greater than 6. 1x and x are the same exact thing. Now, number 4. To get x alone, what I'm going to do is divide both sides by 3. I get x is less than or equal to 3. Number 5. Constants all the variables are on the left. I have to move the constants over. So negative x is less than 4 minus 5 is negative 1. And now I have to get rid of this negative. How do I do that? I divide by negative 1. But when I solve and I undo multiplication of a negative number and dividing both sides by a negative, I go ahead and I flip the inequality sign. And x is greater than 1. Number 6. If I look, I have all my variables on the left. I have to get rid of this constant 6. How do I get rid of it? I subtract it. Line it up under the 15. So negative 3x is greater than 9. We have to remember to bring down the negative 3x. Now, I divide both sides by negative 3, and I get x is, since I divided, did I divide by a positive or negative? I divided by a negative, therefore I have to flip the inequality sign. So x becomes less than negative 3. Now, just because it was not an example here, let's talk about something else. If I give you the problem, let's say 3x is less than negative 12. When I divide this by 3, did I divide by a positive or a negative? I divided by a negative. Therefore, I do not flip the inequality sign. X is less than negative 4. You only flip the inequality sign if you divide by a negative. This is solving one and two step inequalities. Try the next few problems on your own, and good luck.